Okay, the last thing that we're doing with vectors in this unit is we're going to be finding dot products of vectors and the angle between vectors. So as I showed you yesterday, vectors for vectors, we can find their magnitude, we can add vectors together, we can multiply a vector times a number, a scalar, okay? We can also find the angle between vectors, okay? And we can also find what's called a dot product, okay? So let's talk about the dot products first. Let's say that we are given, and I'm just going to do an example of each of these from your worksheet. So let's say that we're given the following vectors. We're given these vectors. And in these first four problems, they ask us to find the dot product of these vectors. So here's how to find the dot product. So for the dot product of u and v, I look at u, I look at v, okay? Now, do not just multiply their coordinates together and write it. The dot product is a number, not a vector. So the dot product is a number, not a vector. So you will not get a vector back, okay? It's a number, not a vector. So we're going to look at these two vectors to find the dot product. I multiply their x coordinates together, and then I add the product of their y coordinates. So negative 4 times negative 5 plus 3 times 2. Okay? So that will be a 20 plus 6, which is 26. The dot product is 26. So if I were to write a formula for that, I would say if u is the vector AB and v is the vector CD, then u dot v is equal to A times C plus B times D. That's our formula for a dot product. Okay? Let's say that our vector had 3 components. What do you expect we would do there? I'm sure you would guess it. Sure you would guess it. So if we have 3 components, we do the same process, but we have another product to add. So if I want u dot v, I'm taking u and v and I'm looking at their corresponding terms. So I have negative 4 times negative 5 plus 3 times 2 plus 1 times negative 3. I'm going to add those together, so we have 20 plus 6, minus 3, and that is 23. So that's how we do a dot product. Easy peasy, not a problem, right? Okay, now to find the angle between the vectors. To find the angle between the vectors, we have a formula that will be given to you on any quiz or test. Okay? So if I want to find the angle between vectors u and v, there's a process to it. I need to first find the dot product, then I need to find the magnitude of u, and I need to find the magnitude of v. Okay? So I'm first going to find the dot product. Okay, so u and v, negative 4 times negative 5 plus 3 times 2 is equal to negative 20, I'm sorry, not negative 20, positive 20, plus 6, and that is 26. Okay? Now I'm going to find the magnitude of u. The magnitude of u is the square root of the sum of the squares of its components. So negative 4 squared plus 3 squared. And that is the square root of 16 plus 9, which is the square root of 25, or 5. And lastly, we need the magnitude of v. So that will be the square root of negative 5 squared plus 2 squared. That is the square root of 25 plus 4, which is the square root of 29. Okay. Now we're going to take all three of these pieces and use our formula. So now we have cosine of theta is equal to the dot product divided by the product of the magnitudes. So 5 times the square root of 29. We want theta. So we need theta is equal to, since we don't know a unit circle value whose cosine is the 26 divided by 5 square root of 29, we're going to use our calculator to find it. So theta will be inverse cosine of that expression. And we are going to find it in degrees. Your worksheet is going to say in degrees. So I'm going to go to my calculator, make sure I'm in degree mode. Okay. And I'm going to go to my home screen. Cosine inverse, or inverse cosine of. Now, two ways to do this. I can put parentheses around my whole denominator. I recently was reminded that these calculators have a fraction bar. Now, not all calculators will have this fraction bar, but these calculators do have this fraction bar, and I hesitate to even show you it. I really do. Let me first show you something. 26 divided by parentheses, because there are two pieces in the denominator, put parentheses around the entire denominator, 5 square root 29. Close parentheses on the denominator, and then close parentheses on the inverse cosine argument. Okay? Now, these parentheses are crucial. We will not get the correct answer if we don't have those parentheses, because it would be dividing, if we didn't have these parentheses here, it would be taking 26 divided by 5, getting that, and multiplying the whole thing by the square root of 29. In essence, it would be putting the square root of 29 up here with the 26, and that's not where we want it. So we have to have parentheses around that denominator. Okay? So we are going to get 15.068 degrees. Okay? The other way that I was going to mention to you, and again, I kind of hesitate to do this because I don't want you to rely on it, because some calculators will not have this feature, and you have to know how to do that. All right? In particular, if you're taking the SAT online, the ACT online, and they are requiring that you use their computer's calculator, it will not have this feature. Likely will not have this feature. So don't rely on this feature. Know how to use parentheses. But I am going to show you how to get this fraction. I did alpha, and now I'm going to hit I want to go to F1. So alpha F1, this n over d, it puts a little fraction in there, and it allows us to type in our expression exactly how we see it. And we don't have to worry so much about having parentheses on the bottom, because it looks exactly like what's on our paper. Please do not use that as a crutch, though. Again, I hesitate to even show it to you. The only reason I'm showing it to you is because just the other day in calculus, my students said that they all use that. It helps them not make errors, and they can use their own calculators for the AP exam, so I'm okay with letting them use that feature. So that is it for finding the angle between vectors and dot product. And that means that's the end of what we are doing with vectors in pre-calculus.